Hello, everyone, and good morning. We're going to get started in just a couple of minutes. We're going to let folks slowly trickle in, and we'll get going in just a bit. Hold tight. We'll get started at about 3 minutes after the hour. Hello again. If you are just joining us, just want to let you know we're going to get started in about just under 2 minutes here, giving folks a chance to roll in before we get underway. So hold tight, and we will be going in just about another minute and a half. Okay, hello again, everyone. Just want to let you know we're giving folks just about another 60 seconds or so here to join us before we get underway. So thank you for your patience. Just hold tight. We will get going momentarily. We want to let you know that you are in the right place and we are eager to get started. So hang tight, and we are about to get the show on the road. All right, it looks like folks are trickling in, so we will get underway. We want to be respectful of everyone's time. So, good evening or good early afternoon, depending on where you're joining us from. Welcome to today's webinar, Replacing Rule-Based AI Ops with Predictive Reliability Workflows. We're very excited to get this webinar started, but before we do, we'll go over a few housekeeping items so that you know how to participate in today's event. So this webinar is a moderated discussion, which means that as an attendee, you won't be able to use your microphone or turn on your camera, but we do want to hear from you. You can use the Q&A feature in Zoom, which is found on your menu bar, to send messages to our panelists and our two hosts today. If you are having technical issues, you can let us know via the Q&A. And we will have a live Q&A session after today's webinar. So you can submit your questions by typing them into the QA window at any time. We will collect those questions and address them at the end of today's presentation. You can also participate today by answering polls throughout this presentation. When we open polls, if you're on a Windows device, polls will appear on the same screen as the Zoom webinar. On Mac devices, they'll appear on the current active screen. Finally, if you miss any of the content or you would like to replay it at a later time, you will receive a link via email to view a recording of this webinar shortly after it becomes available. That does it for housekeeping items. With that, we'll get started. Welcome to today's webinar. And with that, I'm going to ask today's presenters to go ahead and turn on their camera. If I can find the camera button here. There we go. Hello, I'm your co-host, George Miranda. I am currently VP of Marketing at InsightFinder. My career background started as an engineer running large-scale distributed systems, mostly in the video game and finance industries. I'm also co-author of the O'Reilly book, Observability Engineering, So it's fair to say that reliability workflows in production are a very close personal passion of mine. So I can't wait to get started with today's discussion. Also, my co-host today is Dr. Helen Gu, and she is even more passionate about reliability when it comes to AI. So Helen, why don't you go ahead and introduce yourself?
Hi everyone, my name is Helen Gu. I'm the founder and CEO for InsightFinder, and also I'm a professor at the North Carolina State University. Has been working on AI for system management for the past 30 years. So it traces back my first research paper published in 2001 on using neural networks for actually predicting video streaming. Behaviors. And so fast forward to today, and so have been actually using all kinds of AI technologies to tackle system, particularly distributed system problems like troubleshooting and predictions. So very glad to hear to share our experiences and some of our success stories with our customers today here with you.
Excellent. Thank you, Helen. Very eager to get into today's topic. But first things first, I'm going to go ahead and kick off our first poll. And so this poll is asking you to describe your current AI ops state. So the poll is open. We'll leave that open for a couple of minutes so you can vote and tell us how things look in your environment today. But while that's going on, let's talk about today's webinar topic, right? We're going to be very direct around a common frustration. And sorry, I realize that the slides are not advancing. Oh, there we go. Um, very common frustration, right? And that is that a lot of AI ops deployments still feel like they are just event correlation and rules and lots of manual fine tuning, right? A lot of AI ops doesn't really feel like AI, right? And if your management tools become yet another system that you have to operate and you spend time debating and setting and managing thresholds or correlation logic, right? If you have to do constant upkeep, then it feels like the promise of AI, right, and AI ops kind of starts to fall apart. And so our goal today in this topic is to separate hype from reality and talk about what actually works in production. And what we all need in production at the end of the day is faster detection, right? Better prioritization, context around root cause, and ensuring that anything that you do inside of that, incident management process works within your existing workflows, like ServiceNow, for example, right? Like if that's where you work, that's where you need the work to be. And so that's what we'll be looking at today. As a little bit of a preview of what we have in store, we started with a little bit of a quick baseline, right? This poll to understand how your AI ops deployment is looking like today. I see some votes are already in. Very exciting. We'll talk about that in a second. Then we're going to unpack internals like event correlation versus true AI approaches. And Helen will share a real world example, walk through what replacements look like in the real world, right? How we use true AI driven workflows in practice. But before we go into any of that, I think it makes sense to step back a bit because, especially in an AI era, there's a ton of confusion around terms like AI ops and what we actually mean, right? So let's start there. Like, what is AI ops exactly, and how much of it is actually AI because it's a bit of a misnomer. So, Helen, what's your take on that? Like, how much of AI ops is actually AI?
So I think the term AIOps actually started basically around 2006. But actually the concept of AIOps is to use AI technology to automate and optimize our IT operations. So this concept has actually long started before this AIOps term was coined by Gartner, right? And so back in I think around 1999, and people start already looking at using technology like control theory to automatically tune the system, right? And then fast forward to 2001, and so IBM back then to propose the idea called autonomic computing. So to me, that's really the starting point of like using AI technology and to how to optimize the system behaviors, right? That's around the time that my research begins to leverage AI technology in this space. So I think the vision is actually pretty clear, and so we all understand the system becomes so complex, and so just rely on manual effort to debugging, to troubleshooting, to fix the problem is no longer feasible, right? So even back then, in around year 2000, you look at web services. And so when IBM needs to tune their web services, you need to actually tune hundreds of parameters just to make a web server work efficiently, right? And now, fast forward to today, right? That's almost, 30 years later. And so the complexity just like exploded, right? So it's now no longer just IT services, but also the AI and all those things, new development, virtualization, cloud computing. So, the vision of AI ops, I think, is definitely very valid, and still is actually the goal we want to achieve here. But how to achieve this kind of autonomic computing, or really kind of like make the system more reliable, this kind of vision, it's a very hard problem, right? And so people tried all kinds of techniques, right? Like I mentioned, early days, people try the control theory, and just like they feel like they can tune the software system just like they tune a physical system, right? You saw the robots, you saw the manufacturing automation. There's a lot of control theory you can actually automatically control and tune. But then soon people realize the software system is very, very complex, and the most important difference here is the nonlinear behavior of software systems. So that's why basically later on, I think at the beginning, AIOps solution has mainly focused on correlation, right? So people don't understand what's going on, so they just rely on like timestamp to see, okay, this happened at the same time, so they may be related. This is a very strong assumption, right? So because it's more like a black box kind of guess, right? It's a guesswork, right? So we feel, oh, CPU spikes here,
Mhm.
and then response time increases, so they are the root cause of the response time increase. But most likely it's not, right? Because fundamentally this server maybe not talk to even the web server. So that's the problem with the I would say like the traditional AI ops solution, right? So they find the correlations, they find basically the symptoms that happen at the same time, but they are not looking for root causes, right? And
Mhm.
the key thing here for any production system, right, is to look for basically those problems that happen actually way before the incident, because most of the time in our production environments, especially distributed systems, the root cause manifests a lot earlier than the incident itself, right? Because our system is highly redundant, it's complicated, it's basically network, already connected, right? So you don't see like production environments just crash like this, right? So you see basically things propagates, and you see the problem escalates, and then becomes from a small problem to a big outage. So the key thing here for really the AI ops, or any vision of automatic computing, is to actually capture those early on symptoms so you can actually prevent the problem. Yeah.
Yeah, no, I love that because what I'm hearing is, the promise of AI ops and the approach is sound, but maybe some of the ways that this has been executed, especially, given when the term was coined, right? Before we were really in generative AI era, and I think a lot of folks were just doing, like you said, like manual correlations and manual tuning. This is where some of it fell apart, right? And you're absolutely right. Like what we're after after all, is better incident response, right? That's the promise, but it's not quite landing. So I want to check in on the results of our poll. Also, I see that only maybe about half of the audience has voted. So please go ahead, get your votes in as we wrap this up. I will go ahead and publish this one where it is now. And I think what we can see is, yeah, lots of alert correlation and rules, right? Using multiple tools, and then a couple of folks that are just getting started. So I think that is a pretty good indicator, right? I think meaning if you're going down the path of AI ops already, right? You may have multiple solutions. This may be only one part of a tool chain designed to get better incident response, and folks are still dealing with alerts and correlation rules, right? Or in the exploratory phase and just getting started. So. Um, Oops, I realized that I didn't share those results. You can see how they look. And while that's going, I'm going to go ahead and launch our next poll. And while that is going, we're going to lean into what we were just talking about here, which is, oops, there we go. Event correlation, right? What we want to know in this next poll, when I get it open, sorry, having technical difficulties here, is what happens in your incident response process. So I will get that poll started shortly here. There we go. And I think this is a great question because it touches on what Helen was just talking about, right? Which is what we're after in this search for solutions, right? Faster incident resolution is what it's all about. So I can't wait to see where folks think their time is being spent and what is really happening with the tools that they have in place. But let's talk about that for a minute, right? I want to zoom in on some of those things you touched on, Helen, like where things get blurry in the AI ops space, right? And I think that's event correlation versus AI, right? And like, what is it that actually helps you move the needle during the outage? And I think you touched on some of those things. So help us pick it apart, right? What is the difference between these two things? And what's different and what actually works, right? So the difference in event correlation and using a true AI approach. What's your take, Helen?
Mhm. Yeah, I think event correlation is very useful during the early stage of monitoring deployment, right? And so because no matter what kind of monitoring tools you use, and so the ultimate goal for any observability solution is to detect the problems, right? And now what we saw in production environments is because users, operators are so concerned about the reliability, which they should, because given the complexity of the system, the reliability really becomes the top concern for many users. And so a lot of times we're trying to overdo things, right? So we over preventing, we over monitoring, and so we have tons of tools deployed, right? So just to worry about like missing something. But the downside of doing that is that we have tons of alerts come in, and the people either they don't know how to set up the alerts, or basically they're being kind of like conservative. They want to actually get notified when things going wrong, but not necessarily, you know, understanding what's actually the normal behavior. So you see lots of noise in the alerts. And so early days of AI ops focus on how to reduce those alert noise, right? So basically how to get consolidation out of the redundant alerts, or find out, okay, those alerts are coming from the different tools, but for the same instance, right? So some people, we saw many times our customers install like, Prometheus, New Relic, Elastic, Splunk, and Datadog, right? You name it, all kinds of tools, and to monitor the same set of machines. And so a lot of times you see, okay, Splunk, New Relic, and Datadog, they all raise the same alerts because they're setting the same thing as a thresholds. So during that scenario, I would say even correlation is very useful because it allows you to at least to dedupe those redundant alerts. However, that's just the first step, right? So after this first step, and the point is that the moving from those like deduped alerts to the true root cause is a gap. Like, currently there's no support and from the existing AIOps solution, and the operators has to actually still go back to their manual effort to do that, right? So that's basically where I think the difference between event correlation and the true kind of AI driven solution. Now, the
Yeah.
the key thing here is that how to implement this basically from the all kinds of alerts to true root cause is not just actually coming from the alerts itself, because most of the time the alerts are basically very noisy. They are full of false alarms, and at the same time they miss the true signal because they are relying on thresholds. So the issue is not just actually how to select or prioritize those alerts become root cause. We find out for a lot of our customers the true challenge even start before that, right? So before the alerts are being created, because most of the alerting system cannot actually identify the true problems in the system in the first place. And so if you don't solve that first step, like the basic requirement for this AI driven solution, and no matter what kind of AI engine you use, right? You try to throw all those things to ChatGPT and ask ChatGPT for those same question, it's useless because you are not feeding the right signal to the AI model. So in order to make the AI driven solution works, you need to actually first of all to solve how to get the signal and how to actually really transform those signal into meaningful information. Yeah.
Yeah, I went ahead and I just closed the poll. Actually, thank you, audience. Everybody voted on this one. I think there are a lot of thoughts, and it really mirrors what you just said, Helen. So I'm going to go ahead and share these results because I think it makes the point really, really well. Right? These answers are telling, and you can see, right? Everyone is considering alert noise, and that seems to be the biggest draw for AI ops. But right below that, right? Prioritization, context, root cause speed, right? And I think that's the crux of the problem here that you're describing, right? Even with an AI ops tool in place, incident response is still slow in a lot of organizations, right? And the number two concern here is missing context, right? Like tell me more about what is actually happening, not just reducing the noise, but like how do I take that next step? And so I think this is important, right? Because maybe the tool helps you cut down on alert noise by, correlating, all of that noise and condensing it, but it didn't help you understand what's happening and it didn't help you resolve it any faster. And I think this is what happens, right? Teams realize that they have solved a symptom of the problem, right? Like they got that alert storm taken care of, right? So they have fewer alerts. They know hopefully where to better focus, but that still isn't fixing the core issue, right? Which is we want faster incident resolution. And I think that's when a lot of teams decide to change up their approach and figure out like what's the better way. And so I think the question becomes then, right, like how do companies actually make this work in the real world, right? And how do we do that, without rebuilding processes or ripping out tools and workflows and just making this like horribly disruptive, right? And making this a giant migration. And so I think that's the next question that I want to go ahead and put on the table here, which is for this poll, this last poll here, I want to ask about AI migrations, right? Like, what does it look like to go through a migration, right? And how do people do this in the real world? And I think that's what we're going to talk about next year, right? So, if you replace the poll is asking, right? If you replace your AI ops platform, what are your biggest constraints? Definitely want to hear from the audience, right? Like what seems like it gets in your way or like stops you from looking at other solutions? Because I think what we should talk about next is how this is done in the real world, right? Because it's not so easy to just rip and replace. And so Audience, very curious to hear what you have to say. And now I'm turning that question to Helen. So, Helen, can you show us a real example of like how customers do this in the real world?
Sure. Yeah. So I can maybe share slides or you want me?
Sure.
Yeah.
Yeah, I'll stop sharing so you can share.
Okay. Can you see my slides now?
Yes.
Okay, cool. All right. Yeah, so we want to use maybe next 10 minutes to share our experience helping some of Fortune 500 companies to implement this AI-driven reliability services in their production environments. So the key thing I want to emphasize, this problem is more important than ever, right? So we saw the code being produced by AI quickly, and then now basically, software development is no longer the bottleneck. And and you saw basically those multi-agent system are rapidly deployed and adopted by an enterprise. So this kind of complexity is basically is kind of like more complicated, right? And so we are seeing the code being released into production as at this lightning fast speed, and then we see these complex interactions not only between the IT services but also between the IT and the models. And we saw those fragment tools are actually seeing, different aspects, but cannot actually really pinpoint the root causes because they don't have the complete picture. So this has really become the new bottleneck, right? So I think the operation team has basically the burden and the stress higher than ever. So in order to actually make this work, like we mentioned, it's no longer just sufficient to just look at alerts from the IT services alone, or basically just looking at one aspect of your system, right? Because you cannot assume where the problems come from. So in order to tackle this problem, we start with basically as a kind of like, from scratch, we build this AI engine with the goal that you can process any kind of data, right? Not just alert data. So very different from traditional AIOps tools. They only can consume alert data. And from day one, we build our AI engine that can consume any kind of data, right? So telemetry data, trace data, log data, model input, features, any data, right? The reason is that we believe the root cause could come from anywhere. And in order to do the accurate root cause analysis, you need to have a full coverage. And you need to be able to actually extract the signals from those all kinds of raw data, not just rely on alerts, because alerts itself can be highly noisy and inaccurate. So that's basically the first step, right? So after we can get all those raw data being processed by AI technology, and so we kind of extracting what's actually important, right? So from the raw data and using unsupervised machine learning, right? So it's essentially we are now relying on rules to detect the problems, right? Because rules are only tell you what you expect, what you know, but it cannot tell you what you don't know. And so after you actually extracting those anomalous problems, the next step is to look for causality, right? So that's very
Mm.
different from even correlation. So causal analysis is different from correlation analysis. So correlation is, you can think about it as a special case of causal analysis because correlation is looking for something happen at the same time. So, like I mentioned, in real production environments, root cause typically do not happen at the same time. It happens before the major system outage or incidents. So that's basically what the causal analysis is looking for, is looking for like what anomalies happens before that outage that has a strong causal probability with this incident. So that's basically what InsightFinder focus on, right? So um, right off the gate, we basically do not focus on just correlation. We focus on root cause analysis, right? And so this basically allow you to actually go to the root cause, and then you can actually start from there because you can find those early symptoms that happens before the incident, this also give you opportunity to prevent the problem and predict the problem. So we have been working on this with um, quite a lot of Fortune 500 companies, and so what we saw is that customer really like that they can actually use InsightFinder to detect both known and unknown problems, and they all can see like the accuracy of these alert noise, the accuracy of those problem detections are much is become much better because we are employing not just like simple threshold based or rule based alerting. We are doing multivariant unsupervised learning to model system normal behaviors and trying to find all the different deviations, right? And also we are not looking at the one metric or one log, like one type of log, individually. We're looking at things together. And so we can find the problems that basically traditional solutions cannot find. And also, this is a holistic platform you can actually apply to your AI systems, your models, your Gen AI system, your chatbot, as well as your traditional IT services. So this allow you to actually have the full coverage, and so you don't need to actually worry about fragmented tool and doesn't give you the clear picture of root causes. And so the last thing is that we can do that efficiently, cost efficiently, right? So this is also very important, right? So just a few days ago, I was talking to one of customers, and so they basically mentioned they were trying to experiment in the idea, throw their logs into ChatGPT and trying to figure out the problem diagnose. But very soon they realized how expensive that could be, right? um, the Gen AI technology LM is not invented for analyzing like very noisy machine data, and it most of the time they are not doing good job, but also it's very expensive, right? Because they are token based, they will charge you based on the tokens, literally based on the words in your log. And so here inside Finder, we use the composite AI technology, and that basically analyze those noisy log data using basically the right technology, right? We are not just Gen AI is basically for analyzing human language, right? So they are not invented for analyzing machine data. So the other thing that very important is that you need to provide this real-time insights, not just like offline analysis. So that's what where we help our customer to summarize and get everything actually in one place, and then we can present that through a MCP agent. We will provide this summary of all the insights from all the observability tools you have instantly. So one of the basically the promise we made here is that we don't require our customer to change their existing workflow. We don't require them to change their existing monitoring tools. And so what we do here is to plug the AI engine at the right places and to basically provide the insights and the signals to the right solutions they have already in place, like ServiceNow, like Slack, like Teams. And so you can actually view those insights everywhere into your workflow. So this is a recent production deployment we did with a Fortune 50 company. And so they are a former Microsoft customer. And so they have, very complex systems deployed all over the world for their infrastructures. They have over 50 different monitoring tools and to generate all kinds of tools, all kinds of data and alerts. So in the past, basically they have been relying on Microsoft to consolidate those alerts and create some incidents based on the rules. And so the problem is that it doesn't really give them the root causes, right? So when incident happens, they still has to actually struggle. And the second issue is that basically those alerts, even you can reduce alerts, but a lot of times the true root cause is not are not covered by those alerts. So when we came in and basically we look at their current workflow, right? So it's very hard for a Fortune 50 company to change their workflow for InsightFinder. So what we do here is that we saw, okay, they already have all kinds of tools, generate all kinds of alerts. And so it's really the getting those alerts in one place is actually not difficult. The customer already have the kind of Kafka-like infrastructure already aggregate all those alerts in real time. So if you can actually have an AI engine that is powerful enough to process all of that, and that's basically a lot of like really useful information kind of already included in those signals, but it's not actually leveraged today. So the first thing we did is that we basically tap into all those alerts and data, right? And so coming from those different monitoring tools through their streaming interface. And the other thing, what customer rely on is using ServiceNow to actually do all the incident management, right? So they have the responders to check those ServiceNow and process ServiceNow tickets. And as you can imagine, they have like, tens of thousands of incidents each day. And going through all those incidents and figure out the root cause is very, very time consuming. And so currently, in their tools, right, there's no RCA, right? So there's no context when those tickets are created in ServiceNow. So very short description, a lot of times the description are vague. And so there's no kind of like, clue for the customer to figure out where to start. And they have certain rules to also create the incidents, and but those rules are very hard to maintain, and so there's errors in the rules sometimes, and those rules are actually set as basically improperly, and so they have the problem is that many tickets, many false alarms are created by those rules as well. Then lastly, basically customer always doing kind of like chasing work, right? So they always kind of their team is basically sitting there and responding to kind of incidents, right? So there's no proactive alerts for them to actually see, okay, there's a big issue coming, you should take actions now, right? And so that's basically the three things we trying to help them to address is that employ basically anomaly detection in their existing alerting data and perform root cause analysis before those incidents actually getting actually processed by the operator, right? So the moment when those incidents created in ServiceNow, InsightFinder already actually populate the root cause in those tickets. And so InsightFinder is also seamlessly integrated with their ServiceNow already. So we can actually read all those information from ServiceNow, including their incidents, problems, CMDB information. Um, and then basically we can actually update the root cause as a context for their operator in ServiceNow. So their operator does not need to leave ServiceNow, does not need to change the way they work today. So they will still operating surrounding ServiceNow. The only dashboard they need to look at is ServiceNow. But the insights, right, the root causes, the proactive predictions are all automatically populated. And also those redundant incidents are already dampened by our AI engine as well. So as a result, our customer can see basically the root cause context in their ServiceNow tickets before they actually get started on that. And we also provide the remediation recommendations um, um, for their operators based on the root cause we identified. So the other thing we also get is the runbook from the ServiceNow knowledge base, and those runbook information will also automatically integrate it into the root cause summary and recommendation and remediation recommendation. So basically, when their operator actually process a particular incident, he already have not only the root cause context but also the appropriate runbook he can leverage. And lastly, we because we can do this root cause analysis and the causal analysis give us a lot of times the predictive patterns. We saw basically we can actually predict the incidents, 7 8 hours ahead of the incidents. So this basically give their operators not only the faster basically diagnosis, but also have a chance to prevent the issues. So just to wrap up, we have another use case with one of the credit card company. And so here, not only we help them to monitor their traditional IT services, but also their AI platforms. These platforms running all kinds of AI models, including their fraud detection, risk analysis. There are hundreds of models running on top of their infrastructure. And so here we help them to identify the model issues like model drift. When you have fraud detection, if those models has like drift, and so your business will have, the credit card transactions will actually be denied, right? So those are very, very serious problem for them. And so we can help them detect those model drift and the model availability issues within minutes, right? So we provide real-time insights and also help them to perform root cause analysis across models and infrastructures. Yeah, this is a quick kind of like some of the stories, success stories we have with our customers. Yeah.
Yeah, no, Helen, that's a really thorough walkthrough of the workflows and how they hold up under production pressure. You know what I'm going to do here? I'm going to end this poll and share the results because this conversation, I think, is going to go in a slightly different direction than I anticipated. If you look, what a lot of folks are concerned about is trust in AI predictions, which is something that you referenced here at the end. Also, I'm going to go ahead and go back to sharing slides because the next question that I had for us is not showing up. There we go. Um, Sweet. Okay. So, looking at those poll results, right? We are focused on AI predictions. And what I wanted to talk about next was unlocking value and where AI ops delivers. We also have a question about this in the Q&A already, which as a reminder, folks, if you have questions, please put them in the Q&A. Can't wait to get to those. But right now, what I'm seeing is a lot of concerns around trust in AI predictions. And my guess is, and especially based on the question that's being asked, is low trust in some of those predictions,
Mhm.
right? So migration effort has to be worthwhile, right? Teams are busy. They need a clear win to prioritize the work. And it seems like maybe some of that trust in AI predictions is one of the places that AI ops can deliver on if it's done right. So Helen, maybe can you talk to us a little bit about that, right? Maybe the value that customers actually unlock and maybe just touch on the predictions as well, because I know, and especially from my experience in the field, this is a place where a lot of engineers tend to have doubt, right? Like we've seen that those predictions generally aren't very reliable or great. So maybe can you talk about that and some of the value that we deliver?
Yeah, I think the most important thing to gain trust from AI is to make sure AI actually provide evidence, right? And so the AI has a lot of black box inferences, which human brain doesn't operate in that way. So that's why it's really hard to understand. So the most important thing is not just to provide people prediction like saying, hey, something bad will happen. You need to tell people why, right? And so this evidence has to be easy to understand, right? So for example, if you show, oh, there's a memory leak here on your web server, and your web server will crash after 2 hours because you will use up memory. If you explain that to user in this way, and they will trust it because it makes sense, right? And you also need to back with evidence like line charts, error logs, and so all those things. So that's basically what we mean is like causal chains or context, right? So by InsightFinder, when we provide the predictions, we are not just tell people, okay, there's something bad happen. we'll also tell people, okay, here's a causal chain, here's a timeline for those anomalies and how they propagate, and what's the if there's a historical incident happen because of this, we'll also tell people based on this historical causal path, right? So in our knowledge base, this is basically why we make this prediction. And so the other thing we also did recently is to leverage AI agent to collect, really detailed evidence. For example, if we detect, okay, we are predicting this network device will burn down, and then we will basically also collect all the information related to this device, like upstream device or downstream device, to make sure people understand, okay, there's no upstream device will have problem, so this device is the culprit. Or basically we'll say, okay, the upstream device is actually having problem too, and so this device is just like the symptom, but not the root cause, right? So all those evidence will be also collected by our AI agent as well, and so we combine all those information together with the basic telemetry data, right? So the other thing we also notice, telemetry data can be incomplete, right? So a lot of people actually don't necessarily trust the telemetry data as well, because there's monitoring delay or etc. things. So when you receive alerts, most of the time the operator, if you are operator, right? So the first thing you will do is to validate, right, whether this is true or not. So how do you validate is to either like ping that machine or log into that machine and to see, oh, this machine is it indeed down, or is it indeed there's a problem there, right? So those steps are basically very tedious, very time consuming steps, because you don't want to do it during mid of night to get out of your bed to do that, right? And so all those things can be done now with the AI agent, right? So the agent can actually not only consume those telemetry data, but also collect actively, right? Collect those hard evidence, and then present all those evidence to the operator, right? So then they can actually have the information to make judgment call, is this good or not? And this is true or not, right? So again, at the InsightFinder, a lot of things we do here is with a human in the loop to do all kinds of validation or confirmation, right? So we're now triggering like a machine reboot, like without getting confirmation from the operator. So the key thing here is that you want to get notified, you want to give no evidence to the operator, and you want to get confirmation from the operator. And so over the time, you start to actually gain the trust, right? And then basically you can configure the InsightFinder to execute this automatically on your behalf as well. So trust is gaining through time, and so that's what we basically learned from our customers is that um, they want to have their experts to first review those prediction results from InsightFinder, and then after they get an internal team to have the confidence, then basically they will open to everyone, right? And so this is a kind of phased approaches. And so we found this kind of like a gradual phased approach works well with large organizations. And we typically start with root causes, then start with basically curated prediction action, and then basically you can see some of the automation will start to actually take effect. Yeah.
Yeah, I love that. One of the things that we wanted to talk about, right, was like the AI approaches that actually work. But I think you touched on a lot of that, right? If I'm hearing correctly, what you're saying basically is that the bar isn't fewer alerts, right? And like reducing the noise. The bar is faster decisions, right? Earlier signal, like that predictive and preventative approach, and less manual upkeep, right? In a workflow that your teams will use. And I think very importantly, what you touched on, right, is context. That is the hardest part of debugging and understanding systems, right? Like why? Understanding what are the factors behind these decisions, right? And bringing that to you. And I think that is the approach that really differentiates. And so when you talk about like using an AI agent like Ari, right, it is that Ari brings you that context and gives it to you so you don't have to go searching for it, right? And that is the game changer, and that's where you get those concrete, measurable results, right? And I think that's something that teams and their leaders can definitely get behind. So
Mm.
I want to get to Q&A because there are a bunch of really great questions. But Helen, anything else that you would add here in terms of the AI approaches that really hold up? I think you've touched on a lot, but anything else that you want to add?
Yeah, so one more thing I want to highlight is the feedback, right? So I think the feedback loop is very important for AI solutions, right? So like, no AI model is perfect, just like no human is perfect, right? So they will make mistakes. And the key thing here is that you need to have a way for operator to give feedback easily and to collect feedbacks and then automatically feed those feedbacks into the model training workflow, right? So all those things has to be actually happen continuously without basic human supervision. So this is another important piece for the AI models to work. And so that's why our customers like InsightFinder tool because we make the feedback as kind of the necessary step in our basically training loop, right? So we always believe you have to be able to continuously improve and adapt, right? So also we don't just actually throw a generic AI model to our customer saying, hey, you made it work, right? So most of the time this will fail if this kind of approach is presented to you because um, every enterprise is different, every computing environment is different, and any generic model they train over generic technology or generic data won't actually work well, right? So maybe they can answer 50% of the problems, but most of the time the solution they provide to you are not actually exactly addressing your environments. So the feedback driven kind of learning is necessary for any AI model to work.
Yeah, absolutely right. And I think you nailed it. I think, general approach is great, but a lot of your business specific context, which fields are related, which service names are the same, what specific terms mean in your business, right? All of that feedback is necessary so that you get this model to adapt and learn the specifics of the context that it's operating in. We have a ton of questions, so I want to get to one specifically that really caught my attention, which was around trust of those predictions, right? And so the question is, how do you prove incident prediction is credible without rolling it to production? Right, meaning that Helen, you were saying this, right? Like, sort of like after you gain trust, you can roll it out wider. But are there more limited ways to do that, right? The question says, are there ways to build up trust? Because most of our engineers don't think it really works well, right? So how do you see people approach that problem and gain that trust?
Yeah, absolutely. So that's a very very common question we encounter. So basically, what we do here is to actually doing emulations, right? So we basically get the real data from our customer, historical data, but we actually have this kind of emulation capability. We can streaming this data as if it's the live data and perform live processing and prediction for our customer. And so they can see, right? So if they have this kind of tool in place and by replay the historical data, and they can potentially get this predictive alerts like 7 hours or 5 hours ahead, right? And so of course we are now just showcase for one place, and most of the time it's more like it's like a game, right? So our customer doesn't tell us where the problem is or when that problem happened, and so just feed all the data into our AI engine, let the AI actually show okay what's going on, right? So that's basically the kind of the easiest way to validate. And of course, the best way to validate is in live environments, right? So a lot of times, our customer doing basically like the gradual rollout, and so when the developers start to trust us, I mean, like the moment they start to actually see those alerts, and they will basically immediately trust us. I still remember like. We have this customer and who actually runs the operation team, and he was a CTO of the company. And so when we first presented, his response is same thing, right? So I know the system. I don't believe this work. And so in it's a very a kind of rejection, like common rejection we saw. But we say, okay, let's so at that time they are AWS, and we just tap into the CloudWatch data for them. And then and he was actually doing some kind of like, late night debugging. And he said, okay, I intentionally actually, well, he was not, he was like, he always late night, I was actually making mistake, and I know I made a mistake. And the moment he push out, and the Insight Finder alert him saying, hey, this is wrong, and you're going to break your system. And then basically that moment he was like, oh, that's a aha moment. The Insight Finder is watching. So that's the moment, right? And so you basically know something bad happened, and Insight Finder alert you, and then that's the moment you will trust it.
Yeah, and that's fair. I think, especially in deployment scenarios, right, or like known common failure scenarios, that might be a place to look and like slowly build that trust. But I think that's a wonderful example. I think we have time for one more, and I know we're already over time, so I'm going to pick this one since we were talking about it, which is when it comes to feedback loop mechanics, like what feedback do teams usually provide, and how do you capture that or turn it into something useful without burdening the response teams? Oh, so when somebody gives you feedback, like who takes care of that? How does it improve the model? Like what do you usually see? Like, can we talk about that quickly?
Yeah, we work with our customer a lot on this subject actually. So for example, for this recent deployment I mentioned with this Fortune 50 company. And so first of all, they actually building certain fields in ServiceNow, allow their operator to easily give basically feedback, just doing a drop down menu. So this is a good prediction, bad prediction, the good root cause, bad root cause. And so very simple kind of a click a button, they can actually give the feedback, and the Insight Finder will automatically collect those information from ServiceNow. So we will basically collect all those like, sum up, sum down kind of feedback, right? So from the from the ServiceNow, and then populate it into a page called a dashboard called Feedback Center. So we build this Feedback Center dashboard, and put all the feedbacks to our root causes, predictions in one place. So their data scientists or executives, they can see all the feedback. And then we also allow the user to do feedback, like, uploading, right? So if they actually collect feedbacks through internal documents, they can also upload through our website. And so once those feedback get collected, and so we also like, looking at basically, we are not basically required a customer to do a very detailed kind of data feedback, right? So because our algorithm will figure out what data is useful, and how to actually process those information. Those are basically not the kind of the kind of feedback we are looking for. We are looking for very simple feedback, right? This is good prediction, bad prediction, and so those feedback will actually feed into our knowledge base, and the knowledge base will basically look at, okay, under this root cause and this basically the incident, we made the correct prediction, or we did not make a correct prediction. So it's more kind of like a feedback driven kind of reinforced learning, to like tune the AI models. So in this way, the model tuning is basically similar to like supervised learning, right? So it's as if you have some human to teach the AI model. This is correct prediction. This is wrong prediction. But instead of ask the customer to actually explicitly sitting there to label these results, we basically make it very easy in their workflow. They don't need to go into our website or interact with the training process to do that. So essentially, the operator can do that, and essentially, this feedback is collected in through their existing workflow. Yeah.
Yeah, so we integrate that into where you're working, right? Collect it, and then the platform does the rest. I love that. Thank you so much, everyone. I'm looking at the clock and we're very much at time. So thank you. You'll get a follow-up email with a link to this recording. We have a couple of other questions, so we'll go ahead and answer those in the email as well. I want to thank you for your time. Helen, thank you very much. This has been a wonderful discussion, and we will see you all again next time. Cheers.
Thanks, everyone. Have a good day. Bye.